Hi, this is Engineer Ahmed. So in this lecture we are discussing about the control valve sizing software. So nowadays we are doing the sizing using the softwares. Manually also we can do that. We have seen in earlier lectures about the formulas. So how to do it. But nowadays everybody is using the software developed by many control valve manufacturers. So in that, one of the famous software is a Fisher Valve Specification Manager. This is developed by Fisher, which is a famous control valves company. So it will have a lot of features, because it has to take care of whole world applications. So but we'll go as per our requirement. All the basic requirements and understanding is important. Then going through all the features. So first in this we have to open a project, a dummy project. So this is you have to operate this. So a project is opened. So project 1, say, that is the name of the project. So then in that project we have to open a control valve tag. So this is a new tag in this project. New tag means new control valve. So we will take as it is, but in actual project we will have to put our actual instrument tag number of that control valve. So with this tag 1, there is a specification sheet is generated, but it is empty. So we have to complete the data step by step. Now as we selected the tag, so all the menu is opened. First one is a ISA sheet. So this is a control valve specification sheet developed by ISA, International Society on Automation. So it is also similar to specification sheet developed by other organizations. So here they are following the ISA, so it does not matter whatever is there. So this contains all the data, project data as well as technical data, service conditions, valve conditions, valve details, actuator details. So everything it will have. So this is a final product of our sizing. But before that we have to go through all these provisions, all these menus. So then it will be filled automatically. First one is a installation data. So this is a installation data. So as you know, control valve is not alone. So what is the inlet piping, what is the outlet piping, so what are their sizes, what are the pressure conditions, so all these things matters. So that is the installation data. So in this we have to get the information from piping also. So we have to discuss with piping engineers to fill this. Then it will be valve sizing. This is actually we are doing the sizing, means we are calculating the CV, that is a flow coefficient of the valve as per our process conditions. So here we have to enter the process data. We have to select the units also. So process data, as we discussed earlier, we will have a minimum, normal, maximum. We can add a special condition, other condition also if you want to. So we have to fill all this data as much as possible. Process data, we have to get it from the process engineers. Then this yellow is it's a calculated data, that is CV. Our interest is in flow coefficient, that is CV. Based on CV we are going to select the valves. So we have other lot of data. calculated data, but we need not worry at this time. So we have to get the CV, that is important. So then we should go to valve selection. Valve selection as based on the service conditions, CVs, based on CV, calculated CV, and the shutoff class and style, rating and line size. It will offer the lot of options. These are the model numbers of those control valves that is there in their Fisher area, Fisher inventory. So we can study the after selecting the valve, we can study the product bulletin also, that is also there. PDF files are there, that also you can study to check the suitability of the control valve. Then valve construction. So after selecting the valve, that is a type of valve, other things we have to add many other things, that is a materials of construction. So trim size, rated travel, that will come from the selected valve. So other things, body material, packing material, type of bonnet, packing type, all this data we have to enter. Again here we have to discuss with the piping engineers, because we are not a specialist in material of construction. So we have to discuss with the mechanical also. So this will be last of the valve details. Then we should go to actuator selection. Actuator selection means type of actuator. It is a pneumatic type, spring, fail modes, lock in last position, all the details of the actuator also we have to add. As we are discussing, shutoff pressure will come from the valve data, because as we discussed earlier, shutoff pressure is important. That is a worst condition for the valve operation. So for actuator selection and sizing, it will take into consideration the worst shutoff pressure, that is a worst differential pressure across the valve. At that moment, actuator has to apply maximum force to move the plug up and down. So that is a design criteria for the actuator selection. So that will do it. Then we will have a positioner. In the positioner, we have to select all the positioners as we discussed earlier. Positioner is to drive the control valve, to drive the actuator against all the process pressures and other forces, frictional forces, to operate the valve actuator as per the required command. Then we'll have additional accessories. Means many of these pneumatic control valves will have a solenoid which is getting signal from the emergency shutdown system to trip the valve, or to put it in last safe position or in the last position. So that solenoid valve also we have to specify. Then we'll have a limit switches also. Limit switches also to give the full open or full close contacts. So all these things we'll study one by one, and we'll add by taking one example. We'll add this, and finally your ISA sheet is developed. This ISA sheet will go to the vendor to buy the equipment in a project. So first we will go into the installation data. So this installation data, as we have shown here, DEF means all or not for the sizing. Many are for the drawings also, for installation drawings and other things. So that is indicated by DEF. So first the style. We have to enter the style of the valve. So we'll have a different types of globe, angle, ball valve, butterfly valve, many other valves as we discussed earlier. But normally for control loop we'll select a globe type of valve. So we have taken example of water. So for that we will select a globe valve. Then we will go to the rating. Rating means this is a flange rating. Class 1500, class 150, 300, these are standard classes. So we will assume that class 300 is enough for our application. Then we will go to the nominal inlet pipe size. So that is all inches. So we will select a example of 4 inches. Nominal outlet pipe size. So normally for a control valve both sizes are same. So it is also 4 inches. So we can select the pipe schedule also here, depending on your ratings. Maybe schedule 20 is enough for this, or we can enter the thickness also. Then we'll have a end connections. End connections means flanges. Mostly valves will come with a process connection is a flange connection. So based on your class 300 rating, we can select a RF flange, raised face flanges. This is raised face flange. Now the allowable noise measured in decibels, dB audio. So maximum allowable noise is 90 as per organization standard. So when valve is just opening from the full close position or completely closing, so from 100% closing it will give a screeching sound, and so that is also limited, should be limited by 90 decibels. So it should not cross the 90 decibels. That is a standard requirement. Body to bonnet bolts and nuts material. So we leave it as a manufacturing standard. Packing, flange, studs and nuts, we left it to the manufacturer standard at the moment. So now we have to enter the design pressure, design temperature as per your process data. It should be in PSIG and it should be in degrees Fahrenheit. So design pressure may be 200, design temperature may be 140. Example we are taking. So ANSI shut-off class, as we discussed earlier, shut-off class or leakage class. So it should have the option. So we can go with a simplest one, that is a class 2. So if you want to see what is the leakage class, you can go to the help. Here also you can check. So this is the ANSI leakage class. So the same thing we discussed earlier also. Class 2 means the simplest one, 0.5% of the valve capacity is allowed maximum leakage. So that is okay for this. As this class number increases, it will be more severe. So these are all special applications. So for the moment, we'll check only the simplest one, that is a class leakage class 2. So the details of the test procedure is given. So this is all for the mechanical people to judge So we have to select only the leakage class, that is 2. So coming back to our installation data, ANSI class 2 we have selected. If you want, we can enter the service description. Service, maybe we are taking a water, we can enter the water. So with this installation data, we will go to the valve sizing, that is next. Valve sizing. So here we have to enter the process data.